Alright, hey, how's it going, Algebra 2C people? This video we're going to do Lesson 7-5, Part 2. Last week was Part 1, Solving Rational Equations. Now, still the same lesson, still solving rational equations, but here's the difference. Last week's lesson, it was always one fraction equal to one fraction, and therefore we can incorporate cross multiplication as the solving method. This is more. Okay, this is not one fraction equal to one fraction. There's two fractions added here equal to the number 4, which can be thought of as a fraction, by the way, because it can be thought of as 4 over 1. Point is, there's fractions, but it's just not 1 equal 1. It's multiple. Same goes with this example, and then I'll have a couple more examples as well after this. I am going to incorporate what is called the common denominator method. That does not mean we're going to get a common denominator and change the whole problem to the common denominator. Because if you do that, you still end up forcing yourself to work with fractions most of the problem. I'm going to incorporate what's known again as the common denominator method, which is going to, within the first step or two of the problem, get rid of the fractions. Excuse me. So that's how that's going to work. So number one, you still need the common denominator. Now, this one over here, I'm starting out kind of how the worksheet's going to go this week. The only two denominators in the question are 3 and x. They're not the type of denominators that you can factor before you do it. They're just single terms, 3 and x. That being said, the common denominator is 3x. Remember when they're two just independent things? Put them together. Here's what you're going to do though. We're not going to change and make this 3x, and this 3x. We are going to multiply both sides of the equation by 3x. That's the common denominator method. Find the common denominator, multiply both sides by it. That's what it is. Now, I'm just going to show it as one big step. So I'm going to multiply both entire sides by 3x. Now, please understand when you multiply by 3x, the 3x multiplies to the numerators only. Please think of this as over 1. And if you're like, why does it only multiply to the numerator? Because 3x would be thought of as 3x over 1. Numerator multiplies to numerator, denominator multiplies to denominator, so technically the denominator is over 1. Times 1 doesn't change these. So here we go. Now I am going to not fully multiply these yet. I'm going to leave them in multiplied pieces. You'll see what I mean. This is a little tedious, but it's important to you understanding it. So when this multiplies, we're going to call it 3x times 4 over 3. See, multiplies to the numerator, doesn't change the denominator. Plus, distribute here. We think of that as 3x times 2 over x. Equals, we think of this as 3x times 4 over 1. Now, here is the critical point. Please note that everything in the numerators is all multiplication. There's no addition in those numerators. That means everything's eligible to reduce. And you're going to notice everything reduces in terms of I won't have a denominator anymore. So in the first fraction, the 3's reduce, leaving me x times 4, which is 4x. In here, the x's reduce, leaving us 3 times 2, which is 6. Now in the last fraction, nothing really reduces, but that's okay because the denominator is just 1 anyway. That's irrelevant. So I do have to multiply that all together, and that's 12x. So look at that. That's a relatively okay equation to solve. It's not a fraction anymore. That's what's really nice about this. So that's just solve. So number one, let's finish this solve, people. Get the x to one side. And I know you don't always like this, but the number sitting here, the 6, I'm going to move the 4x over to there. So I'm going to subtract 4x. And I get 6 equals 12 minus 4 is 8x. I'm actually going to move that up here where I can see it better. Divide both sides by 8. 8's reduce, and I get x equals. You can either reduce this 6/8 to 3/4, or you can just, if you did divide it, do 0.75. And that's that. Now, what I do want you to do with these problems, and it's going to say this on the worksheet, to solve equations, check for, to use a fancy word here, check for extraneous solutions. Anytime you have fractions, especially with the x in the denominator, sometimes things can get a little bit messy and a little bit screwed up, if you will. So you want to check your work to make sure it's equal. Now, on this side, that means I need to do 4/3 plus 2 over 0.75, and if I hit equals, it should say 4. And if you look at that, it does. So we're good to go there, and we checked that. Okay? Let's move on to the next one. Just maybe a tiny bit more complicated. It's got more denominators going on, so it's a little bit fussy. Now, if you look at your denominators, they're 2x, 4, and 2x. We need to work with all denominators, so the common denominator would be 4x. So the 4 works with the 2, and the x works with these two. It works with all three at once, okay? So the common denominator is 4x. We are going to multiply both entire sides by 4x. Remembering that the 4x multiplies to the numerators only, it's technically 4x over 1, so 1 times all of these stays all of these. Okay, here we go. Not going to multiply yet though, so we're going to say that is 4x times 5 over 2x plus, it's going to be 4x times 1 over 4 equals, all the way to there, 4x times 9 over 2x. And the same thing that happened last example is going to happen in this example too, in just a slightly different way. But all of your denominators are going to reduce. Now you got to be careful. So again, everything in the numerator is multiplication, everything in the denominator is multiplication, which means each fraction, anything you want can reduce as long as it does. So here, the easiest part is the x's reduce, but here you have to 4 over 2 reduces in terms of 2 goes in once, 2 goes in twice. Which means what's left here is 2 times 5, which is 10. Okay? Gotta be careful there. Over here, a little bit more straightforward. The 4's reduce out, and I'm left with x times 1, or just x. And then this third fraction is similar to that first fraction. The x's reduce out. And then 2 goes in once, 2 goes in twice, and I get 2 times 9, or 18. Now, this is kind of a crazy situation because that's one of the nicest equations for us as an Algebra 2 group to be able to solve, because all I have to do here is subtract 10 from both sides. And I get x equals 18 minus 10, or 8. It is critical that I check this. Now this one's a little bit more straightforward to do mentally because the answer came out 8 instead of like 0.75. I still need my calculator to help me, but here's what I'm going to be saying. So my first fraction to check is 5 over 2 times 8. So 2 times 8, 16. So it's 5/16 plus 1/4, which is 9/16. And then I check that versus here. Now that's 8, so 2 times 8, 16, 9/16. That checks. So we are good there. So that's kind of the intro to the first part where the denominators don't require any factoring and they just require us to get the common denominator and use it. I'm going to pause a minute, put 2 more examples. Actually, I think I'm going to put 1 more example up depending on how much board space it takes, and then we'll go from there. Okay, I decided to put both examples up. I think I got enough board space to work this out. So let's check this out. Okay, so now the problems look a little more complicated. And quite honestly, if you look at these denominators right away and see multiple fractions, it's not just simple 1 fraction equal 1 fraction. That's why we need this method. The denominators are more complicated looking, but they still don't factor. So finding the common denominator is not going to be as tough as it could be. If we were in class still, like physically in the classroom, we would do a little bit more advanced, but have to be reasonable here, teaching from a distance. So here we go. Now, if you look at the 3 denominators that are present, there's 2 of them that are x minus 6 and 1 of them that's x. Nothing factors, so the common denominators are the denominators put together. Now, I don't need to use x minus 6 twice, so the common denominator is x times x minus 6. That's what I'm going to multiply both entire sides by to do this common denominator method so that fractions reduce. Okay, so there's the x times x minus 6. We're going to distribute this here. Remember, we don't multiply together yet because we need things in pieces so we can see what reduces to make this solving as easy as possible on us. So this will be x times x minus 6 times 5 all over x minus 6. This will be x times x minus 6 times 1 over x equals, and then all the way over here is x times x minus 6 times x minus 1 all over x minus 6. So again, I know that's confusing looking sometimes, but like at least in this situation, you can just stop the video, back it up, and kind of look how I didn't simplify anything, I didn't distribute anything, I just kept everything in pieces. And now, it's important to note that the group like x minus 6 has a multiply in front and a multiply in back, and here, and all these, the x minus 6 and x minus 1 and the x are all separated by multiplication. Which means the x minus 6 and the x minus 1 as an entire group can reduce if necessary. Parts of the x minus 6 cannot. Like just the x, no. Inside there, no. Just this minus 6, no. So if I look though, everything will reduce. In the first fraction, the group of x minus 6 reduces, leaving me x times 5, which is 5x. In the second group, the x's reduce, those x's, leaving me x minus 6 times 1, which is just x minus 6. And then over here, the x minus 6's reduce out as a group. Here's where you can see this is going to get trickier. It's x times that. And I do need to do this multiplication because my fractions are gone. I need to concentrate on solving now. That's x squared minus x. Okay, so the board space is a little bit funky. I'm going to separate this right here. because I am going to utilize this empty space over here. But here we go. For this, I'm going to do this one last step down here and then move up to here. Because there's an x squared in the problem, I want everything on that side to keep everything positive. Before I do that, there's like terms over here, so we get ourselves a 6x minus 6 equals x squared minus x. Okay, there we go. Now I'm going to move everything this way, which means subtract 6x from both sides and add 6 on both sides. Which means those cancel, that gives me 0. And that gives me x squared minus 7x, because that's minus 1 minus 6, so minus 7x plus 6. Kind of messy there, that's why I'm going to move this up here. So because it's the x squared 7x 6 type thing, we're going to factor this. It will factor. The alternative would be go to the quadratic formula. Not trying to do that to you right now. So leave the 0 right here. Now, the fact that this middle number is minus, but that's a positive, we need to multiply to positive 6. It's going to be minus minus. Because 2 negatives multiply to a positive, and it's going to be 1 times 6. That gives me 6. But when checking the distributive property, that's negative 6x, that's minus 1x, and when combined, negative 6 and minus 1 give me minus 7. This is good. You are supposed to set x minus 1 equal to 0, x minus 6 equal to 0, and solve. Add 1 here, you get x equals 1. Add 6 here, you get x equals 6. Okay, now let's watch carefully, people, because we need to check these answers. Now, we're not going to fully check them. I'm going to bring about the issue that, you're like, how can some of them not work? We did everything so nicely and everything worked out so well. The 1's not the issue. I mean, just think about this for a minute. If I put 1's in for all those x's, 1 minus 6 is negative 5. I can put a 1 there, can put a 1 there, can put a 1 there. It's okay that that's 0. Okay? 0 over, so let's just check this. And I'm going to kind of check it mentally. If I put a 1 right there, 1 minus 6 is negative 5. 5 divided by negative 5 is negative 1. Just kind of put a note there, negative 1. If I put a 1 there, 1 over 1 is 1. You can already see that this is addition. Negative 1 plus 1 would give me 0. 1 minus 1 would be 0. 1 minus 6 would be negative 5. 0 over negative 5 is still 0. We get 0 equals 0. We get a check. Here's the issue. If I go and plug this 6 in for this x, and it's an issue right here, right off the bat. 6 minus 6 is 0. 5 divided by 0 is not allowed. You can't divide by 0. It's called undefined. So this answer will not work, needs to be crossed out. That's the only answer. It worked, we already checked it, but the 6 gets put in here and here, gives me 2 undefined areas. Can't happen. Okay? That's why this is tricky, even though this is kind of the nicest version that we've covered. Anyway, let's go to this one. Now this is our last example because the assignment will cover basically based off the examples I'm doing. I am going to start out by putting this over 1 because I like if some parts of the problem are fraction, I want the whole problem to look like fraction. And if you see that in one of your assignment problems where you got, hey, fraction, whole number, put it over 1. Now it's like everything else. It's similar in the sense that, this denominator doesn't factor, this denominator can't, it's just an x. The common denominator is this times this. In other words, it's x times x minus 5. That is what we'll multiply by. X times x minus 5. So that starts out by going to this numerator, which will be x times x minus 5 times x minus 4, all over x minus 5. See, no multiplication yet, because I need to reduce, and I won't see it if I multiply yet. Plus x times x minus 5 times 5 all over 1 equals x times x minus 5 times 4x. I didn't need to put that in parentheses, but it's okay. All over x. Okay, so this one's looking like it's got a little bit more going on, but here's the nice saving grace. Things will reduce so that I do not have fractions anymore. Over in this first fraction, the x minus 5 reduce. Denominator's gone. I got to put this together, which will be x squared minus 4x. Over here, because it's over 1, nothing reduces. Now, got to be careful here. See how this is x out here and 5 out here? You got to think of this as just saying 5x out here and not have that there. And then distribute. So that'll be 5x squared minus 25. Minus 25x, excuse me. Okay? Lastly, the only thing that reduces over here, this group of x's come out. And I got to put this together, which will be 4x squared minus 20x. Okay, so there we go. Kind of a messy deal, but the fact that there is x squares and x's mixed together like the last question, that means eventually I got to clean this up a little bit. But I'm going to get all the things on one side equal to 0 because x squared and x, when they mix together, it's either quadratic formula or factoring. I do have like terms over here to kind of clean up first. The x squares are 1 and 5, so that's 6x squared. The minus 4x minus 25x is minus 29x. Equals, and then over here this is just still 4x squared minus 20x. Okay, so that's that. Kind of the crazy thing about this problem is there's just no regular number, like everything's x related. So either way, I don't care if it's x squared and x going on, everything's going over here. I move everything to the side that keeps my x squared positive. So I'm moving everything to the left this time. So I'll be minus 4x squared and adding 20x. Which will leave us 2x squared minus 9x equal gone 0. Okay, I'm going to move that up here. And we're going to factor this. Now this is kind of an interesting factoring because it's just greatest common factoring, and the only GCF that it has is x. Like I pull the x and then I'm left with 2x minus 9 equals 0. That's all that it can factor. I am to take this and this, set it equal to 0, and solve. So if I set the x equal to 0, there's a solution. If I take the 2x minus 9 and set it equal to 0, I have to add 9, which gets me 2x equals 9. Divide, so add 9. Divide by 2. And that gets me x equals 4.5. So, as I close this video out, people, I have to check those two answers. I can't just say good. I can already tell you right now that 0 is going to be an issue. And again, it's only about the denominator right now, but if I put a 0 right there, we're okay. 0 minus 5 is negative 5, that's fine. But right there, you put a 0 right there, you got divided by 0. That's unallowed. So this answer is getting crossed off immediately, as that's what's called that extraneous solution. It's an extra solution that just doesn't check out. 4.5, we should check. It's kind of a pain. So if I do this, let's check that, and it's in the original equation. So 4.5 minus 4 is 0.5 divided by 4.5 minus 5. This part comes out negative 1 plus 5 is just 4. So the left side, when I plug in 4.5 for x, I get negative 4. Over here, if I do, not negative, I get positive 4, sorry. Negative 1 plus 5 is 4. Over here, if I do 4 times 4.5 divided by 4.5, I get just 4 as well. So the 4.5 checks out and we're good to go. So it can be kind of a challenging assignment, people, but what you've seen is like the assignment will look. There won't be anything too drastically different. So yeah, good luck with it. Shoot me questions via email or Google Classroom private message. I will post this answer key Wednesday a little earlier so you have time to look at it and kind of process it, and I'll try to show every step I possibly can in the worksheet so that it looks fair to you. All right? Take care, you guys. We'll see you later.